YouTube live check.
Good morning, all of you. We will start this session in 5 minutes. Our first guest is also coming.
Good morning, everyone. With the permission of Principal Sir, we will start this program. Sir, shall you start the program?
चालू करून टाकू ना. Respected Charu Arora ma'am, are you here?
Yes, sir. I'm
Yes,
here.
yes. Welcome, ma'am. Welcome. Thank you so much for
Thank you
joining.
so much.
Yes. Can we start, ma'am, this session?
Yeah, sure.
Yes. Dr. Smith, ma'am, please start.
Should I start?
Yes, sir.
Yes, ma'am. Yes.
Very good morning to everyone present here. On online platform, I am Dr. Smita Kharkade, Assistant Professor, Department of Chemistry. A very warm welcome to all the dignitaries, organization director, respected professor, dear students, and our esteemed guest, Dr. Charu Arora ma'am, Professor and Head of Department Chemistry, Guru Ghasidas University, Bilaspur, Chhattisgarh, who have joined us today for this online one-day national seminar on chemistry for innovation and sustainable development, organized by the Department of Chemistry, Sri Lemde Patil Mahavidyalaya, Mandad, under RTM Nagpur University, Nagpur, in collaboration with Guru Ghasidas University, Bilaspur. To begin the formal proceedings, Lamba, Principal of Sri Lemde Patil Mahavidyalaya, Mandad, to deliver the welcome address and extend a warm welcome to our esteemed guest and participants.
Thank you, madam, and a very good morning to everyone present here. It is my great pleasure to welcome you all to the one-day National Sustainable Development, in short CSID 2025 This seminar is organized by Department of Chemistry, Silindri Mahavidyalaya, in association with Rashtrasan Tukadoji Maharaj Nagpur University and Guru Ghasas Central University, Bilaspur. The theme of this seminar is highly relevant in the today's time, as chemistry plays a vital role in addressing global challenges like clean energy, green technology, and sustainable living. And I hope this platform brings together researchers, academicians, and solution for a sustainable future. On behalf of our college and entire management, I, Dr. Navneet Lamba, officiating principal, extend my warm welcome to the invited speaker, Dr. Charu Arora, Professor, Head of, as well as to Dr. Vijay Ji Maharaj Nagpur University. Both the speakers have made remarkable contribution to the field of chemistry as well as on the sustainable development, the academic gathering, and we look forward to learning from their insights and experiences. With these words, I want hope that the seminar will an enriching and inspiring experiences for everyone. Thank you, Master.
Thank you, sir, for your gracious word of welcome. Now, I request respected Dr. Pankaj Mishra, sir, Head of Department Chemistry, to present the introductory remark and brief us about the seminar.
Thank you, ma'am. Thank you very much. I'm Dr. Pankaj Mishra, Head Department of the Limited Mandar. Uh, I welcome all of you in one day national seminar on chemistry for innovation. Full and sole responsibility to introduce this seminar, which we have organized today on dated 3rd of September 2025, to share various innovative work in the field of chemical sciences for achieving sustainable development. Ladies and gentlemen, esteemed guests and fellow participants, it is my pleasure to welcome you all in one day national seminar on chemistry for innovation and sustainable development. Today, we gather to explore the pivotal role of chemistry in driving innovations and achieving sustainable development. We all know that chemistry is the backbone of various industries from pharmaceutical to material sciences and play a vital role in addressing global challenges such as climate changes, energy, environmental sustainability, etc. Today, we are here to share their knowledge, experiences, and insights. Or will be inspired to harness the power of chemistry for better future. I hope this seminar will foster collaboration, innovations, and deeper understanding of the subject, ultimately contributing to the betterment of the society. Dear participants, by participating in this seminar, you will have an opportunity to gain insights from renowned of chemistry, learn about the latest development and trends in chemistry and its application, network with fellow researchers, students, and industry professionals, and explore potential collaboration and opportunities for future research and projects. So let us begin this enriching experience and make the most of the opportunities that lie ahead. Thank you, and I wish you all productive and engaging seminar. Thank you very much.
Thank you, sir, for setting the perfect tone for this today's discussion. Thank you very much, sir. Now it's time to begin to introduce the speaker. I invited respected Dr. Department.
Hello. Am I audible?
Yes, thank you so much, ma'am. A very good morning, everyone. We are happy to see you all together here. Firstly, I thank you all for us here at this program. Welcome to our national seminar on chemistry for innovation and sustainable development, CISD-2025. Dr. Mahesh of this national seminar. I am truly privileged to have with us a distinguished ma'am, who guest speaker, Dr. Charu of FTC, Professor, Department of Chemistry, Guru Ghasidas University, University, Pune, Bilaspur, Chhattisgarh, India, and her dedication to both academic and innovative teaching methods has more made her a respected figure in the scientific communication communities. I want to share CV of ma'am. Ma'am is a professor in a department of chemistry, Guru Ghasidas University, a central university, Pune, Bilaspur, Chhattisgarh, India. Academic qualification of ma'am is PhD in chemistry, bioactive natural products, Gurukul, Kangri University, Hardwar in 2003. Qualified NET conducted by UGC, CSIR, MSc in IIT Roorkee, former University of Roorkee in 1995, secured first division. Ma'am has more than 22-year experience in a graduate and postgraduate teaching field, over 17-year experience in the research and development of material science and botanical pesticide using sustainable development. Ma'am also expertise in isolation, purification, characterization, analysis, and technology. Ma'am has handle a number of major research projects from the BARC funding project, Asian Development Bank funding project, NTPC funding funded project on a different topics, WRI WRIC supported project, and from the university UGC also. Ma'am also PhD thesis supervisor, one PhD awarded to registered postgraduate project thesis supervisor, near about 55 MPhil PhD students, and MSc supervisor. Ma'am also awarded number of skill got a medal of ITIC, Horticulture Society, got Science Initiator Award by Scientific Education Research Society. Ma'am also organized fresher courses as a coordinators, national workshop, also sessions, and also chairperson in the technical session. Ma'am also awarded Gold Medal Award, Best Paper by CCI Fellowship Award, Young Scientist Award, Best Paper Award. Really beautiful biodata, ma'am. You have membership in life member in Institute of Mass Spectrometry, life member of also level like Singapore, Malaysia, Thailand, and ma'am also two patents. Ma'am also a number of 50 research paper in a national books and investors international more than 20 per presented in a conference more than 40. It's a very big and beautiful biodata you have, ma'am. And thank you so much accepting our this invitation. Ma'am, can you please start your session?
Yeah. Thank you so much. First of all, a very good morning to participants. And I would like uh, I would like to thank the organizer and Dr. Mahesh Kedhane for giving me the opportunity to share my some of research finding with all of you. Thank you so much. Should I share my screen?
Yes, ma'am, you can share your screen.
Please. First of all, I would like to. Am I audible?
Yeah.
Yes, ma'am, you're audible. Please proceed.
Yeah, I would like to give a brief introduction about my university. It was established in 1983 as a state university of Madhya Pradesh. In 2009, it was elevated to Central University. It's a lush green huge campus and providing quality education to more than 10,000 UG, PG and PhD students. There are about 350 PhD students. We have 11 schools and 32 departments in our university. A brief introduction about my academic career. These are the positions, teaching and research positions held by me at different institutions. I have published around 70 research papers, 32 book chapters, and 5 books. These are some international journals in which I have served as peer reviewer, and 2 journals whose I have served as a member of editorial board. These are some awards and recognition. Now let us start.
Screen is not visible.
Pardon?
Your screen is not visible.
Screen is not visible. Okay.
Sir, visible, sir.
I'll
Screen
again
is visible,
share.
ma'am. Ma'am, it's visible. Ma'am, it's visible.
It was visible clearly. There may be some problem with the participant, but your screen were visible clearly.
Is it visible now? Is it visible?
Yes, ma'am. Yes.
Yes, ma'am.
So today we are going to discuss about application of nanoporous material, development of nanoporous material, and their application in sustainable remediation. So as you all know that nanoporous materials are porous in nature, they possess pore, and as a result their surface area increases to a great extent. And due to high surface area, they exhibit various properties in removal of pollutants from water, air, or soil. They have application as adsorbent, nanoreactors. They have applications in fabrication of sensors, drug delivery, chemotherapy, supercapacitor, etc. Today we'll discuss about some materials which have been developed from natural waste like agricultural waste or the ashes produced using agricultural waste, graphene oxide. Graphene oxide, as you all know, they are a 2D structure 2D structure and is an oxidation product of graphite. This is the 2D structure of graphene, and due to their unique chemical and physical properties, they possess high surface area, high pore volume, surface functionality, uh, and it gained immense attention among the researchers for its application as absorbent and other processes for environmental remediation. In this table, various methods for synthesis of graphene oxides have been summarized. We have prepared the graphene oxide using modified hammer methods. This slide consists of various derivatives of graphene. And here we have shown various applications, including environmental application. It is used for removal of toxic gases. It is reported to have used in fabrication of sensors. It can be used for absorbing carbon dioxide gas and other toxic and absorption and removal of other toxic pollutants. Second class of compound which we are going to discuss today are metal organic frameworks. They are porous crystalline materials, and they are composed of metal center and organic linkers, and the metal is locked into a position to produce a rigid porous geometry and connected through a metal is connected to different organic linkers. They are also known as porous coordination polymers. They are named, their nomenclature is not very systematic. They are named on the basis of the institution where these have been synthesized normally. They are also known as coordination polymers, and similar material without metals are also used in various applications. They are known as coordination organic framework. If metal is involved, then it is termed as metal organic framework. If metal is not involved, then it is known as covalent organic framework. This is a typical diagram of metal organic framework. This is a organic linker node combined with the metal and resulting in metal organic framework. These are characterized by their high porosity, substantial pore volume, and significant thermal stability due to robust bonds such as carbon-carbon, carbon-hydrogen, carbon-oxygen, and metal-oxygen. The flexibility of organic ligands and the role of counter ions is very important in establishing the geometry of metal organic framework. The naming convention for metal organic framework can be categorized based on their composition, topology, and structural features. We have developed various nomenclature on these three bases. Although the abbreviation MOF is normally used as a general word for this class of compound, like MOF 5, MOF 101, जो लोग काम करते हैं, they must be knowing about this. And the main component of the MOF structure are primary building unit, organic linker, and secondary building. They can be classified on the basis of dimensionality and on the basis of their dynamic behavior. For example, 1D morphs, two-dimensional morph, MIL 53, 2D morph are MLs, as is visible in the slide. They are MIL 73, this is example, and some mixed morph. On the basis of dynamic behavior, we can classify it as rigid static framework and flexible dynamic framework. The first one is rigid and second one is flexible. You can see these rings are flexible in nature. On the basis of their thermal or chemical stability, we can classify like thermally stable or thermally unstable, chemically stable or chemically unstable morph. If we talk about the physical properties, first and most important thing is stability. The direct approach to enhance morph's stability is to strengthen the coordination bond between secondary building unit and organic linker. Several water-resistant morphs have been extensively researched, including chromium-based MIL 101 series, zeolite image, and metal azulate framework. These are example of this type of morph. Another important thing is thermal stability. It is essential for application requiring elevated temperature. So some morphs like MIL 101, these are thermally stable. So these can be employed in elevated temperature conditions. Another important physical property is pore size and surface area. That is very important because the pollutant having compatibility with the pore size of the morph will be easily removed from the pollutants or effluent. And high surface area is most important for removal of pollutant, as it is adsorption is a surface phenomena, adsorption or catalysis. These are all surface phenomena. So high surface area will favor the processes of remediation. Metal organic framework are porous with a range of pores, high pore size and surface area. These properties make them ideal for various applications, including gas separation, gas storage, catalysis, sensing, and environmental remediation. If we talk about the synthesis, in our laboratory, we have used solvothermal method. Simply, the reaction is proceeded at elevated temperature or fixed temperature. It is refluxed at higher temperature for several hours and washed for removal of unreacted reagents. There are various other methods like mechanochemical, slow evaporation, somochemical, electrochemical, microemulsion, various other methods which can be used for synthesis. There are various factors affecting the synthesis process, like effect of metal ion, the coordination environment, stability, and general framework properties are determined by the metal source selection. Second is organic linker. They are very important. They are used in synthesis, influencing greatly the structure, characteristic, and possible applications of metal organic framework. By changing the linker, we can change the properties. And another important factor is temperature. It has a significant impact on the rate of nucleation, crystal formation, and solubility of reactant. High temperature promote higher crystallization, which produce massive high quality crystal and also changes the morphology of the metal organic framework. The coordination environment of the metal ion and the deprotonation of organic linker are governed by pH. So pH is another important factor. Another one more factors affecting is the solvent is a liquid which dissolve the metal precursor. Some common solvents which are used are shown in this slide. And metal organic framework are known for various applications, including gas adsorption, application as catalyst, application in sensing. They are also known to possess antimicrobial property. They are used in removal of pollutant. They are used in chemiluminescence and various other applications. This in present lecture, I will discuss some result of removal of synthetic dyes using metal organic framework, graphene oxide, and waste. If we talk about this production and amount of synthetic dye released from various industries, you can see from this slide that the quantity is increasing every year. And it lead to serious environmental threats because most of the industries do not treat it before disposal. So it is very important to treat the industrial dyes, polluted effluent to be treated before disposal to the water bodies. Because synthetic dyes are generally carcinogenic organic pollutants, they have adverse effect on human health, eyes, skin. They cause dermatological problem, nausea, vomiting, cancer, and sometimes some toxic dyes and even damage DNA. If we classify the dye, we can classify as solvent dye, reactive dye, direct dye, which is directly applied to fabric for dyeing process, dispersed dye on the basis of uh, its chemical nature, we can categorize as acidic dye, cationic dye, azo dye, sulfur dye, etc. On the basis of origin, we can categorize dyes in the class of natural dyes and synthetic dyes. Synthetic dyes are extensively used in various industries, and natural sources like plant. A very common natural dye is isolated from Butiamonosperma palash. A natural dye can be applied on textile with the help of mordants, which have an affinity for both coloring matter as well as fiber. Various methods can be used for removal of dyes like irradiation, ozonation. Broadly, we can categorize these remediation method to chemical method, physical and biological method. Chemical method include electrochemical destruction, coagulation, flocculation, irradiation, ozonation. While physical methods of adsorption, reverse osmosis, ion exchange, and nanofiltration. Several biological methods are also used, like several bacteria and fungi. They can adsorb the dye. Algae can degrade. Enzyme can also degrade. So these are various methods for remediation of toxic dyes. Several physicochemical techniques and biological techniques have been used. These techniques are listed in this table, like adsorption, filtration, coagulation, flocculation, radiation, electrochemical, photochemical degradation, sonochemical degradation, osmosis, biodegradation, precipitation, oxidation, ozonolysis, sedimentation, and ion exchange. The various materials have been investigated as adsorbent due to their efficiency and cost effectiveness. Some examples like activated carbon, sand and sediments, agricultural waste, aluminosilicate minerals, polymeric composite, graphene oxide, metal organic framework, biochar. These are used for removal of these toxic substances. Conventional adsorbent often lag behind advanced material like metal organic framework, graphene oxide, nanocomposite, offering higher adsorption capacity, faster kinetics, and better reusability. Uh, uh, I have incorporated some basic things used in the present study for students who can initiate their research with minimum resources. This method of study or research is very simple. We need only a spectrophotometer, and with the help of some mathematical calculation, some glassware is also needed, some glassware and a spectrophotometer, that's all. And with the help of some mathematical calculation, we can carry out our research work with minimum resources. Dye removal, we should know some formula for this type of a study. Dye removal efficiency. It is calculated using this formula, C naught minus CE. C naught is dye concentration initially minus CE. CE stand for concentration at equilibrium. When equilibrium is attained, the maximum removal is attained into 100 by C naught. Dye uptake capacity, QE, in terms of milligram per gram, can be find out using this formula. We can also calculate thermodynamic parameters using this Van Hoff equation. All the symbols, meanings of all the symbols have been given in this slide. Then we can find out the adsorption isotherm model using these equation. You all are familiar with Freundlich and Langmuir adsorption isotherm. For this, we plot between log CE versus QE, and for Langmuir adsorption isotherm, we plot CE versus CE upon QE. Similarly, for Temkin adsorption isotherm, we plot a linear graph between log CE versus QE. Study the kinetics using the equation for pseudo first order, pseudo second order, and intraparticle diffusion. For this, we plot T versus log QE minus QT. For second order, we obtain a linear plot of T versus 1 upon QE. For intraparticle, linear plot of square root of T versus QT plotted. Here K1 is rate constant for first order kinetics, K2 is for pseudo second order, and Ki is for intraparticle diffusion model. Now first we'll see some result of removal of crystal violet using graphene oxide as adsorbent. This work has been published in desalination and water treatment. Crystal violet is a very toxic dye and belong to class of triphenyl methane dyes, which is used for various purposes such as dermatological drug, biological coloring, textile coloring, and paper printing, etc. They are highly toxic or carcinogenic in nature. It is one of the major sources of pollution and causes harmful effect on environment and human life. It is important to remove this dye from the industrial effluent. Graphene oxide, we have already discussed that it is a layered structure, and when it come in contact with the crystal violet dye molecule, dye molecule get absorbed on the graphene oxide. It was synthesized using modified Hammer's method and characterized FTIR, XRD, and SEM. This is this slide is showing the synthetic methodology and characterization. First one is IR of the synthesized product and its signal. Second figure is showing the XRD. Third one is SEM image. And last one is showing the BET surface area. Now these are the result obtained by us. We studied effect of concentration, and it was found that on increasing the concentration of dye, the removal percentage increases. With contact time, again it increases. Effect of pH shows that maximum removal is obtained at pH 9, means basic medium. As we increase the dose of graphene oxide, the removal efficiency increases. Again, on increasing the temperature, the removal efficiency increases. Then adsorption isotherms were plotted. These are Freundlich, Langmuir, and Temkin adsorption isotherm, showing that Temkin is the best fit one because the value of coefficient of correlation R square is maximum for Temkin. Value is 0.94589. These are the plots of adsorption kinetics, showing that intraparticle and pseudo-second order are the best fit one. Again, the column studies were carried out to find out its practical applicability of the material. In laboratory, we carry out the experiment in batch process. We need to use in form of huge columns. In columns, we fill the adsorbent and the fluent is passed through the column before disposing the effluent to water body. So we got a good column results in this case. So we can conclude that graphene oxide is efficient adsorbent. It is more efficient at basic pH. It was best fitted by Temkin adsorption isotherm. Kinetic study indicated that process is exothermic in nature. Pseudo second order was best fit if we talk about kinetics. And through column studies, it was observed that graphene oxide is promising material for industrial application because its efficiency was very good for removal of crystal violet from the solution of 50 ppm concentration in very short time. Another study we are going to discuss is bioadsorption of crystal violet using aerial part of Chenopodium album. This work was again published in Desalination Water Treatment. Chenopodium album is a fast-growing weed which is undesired by farmers. Its aerial parts are often considered as a waste material, so they have very limited use in commercial application. The non-edible part which has been discarded can be used for removal of pollutants. Again, we have already discussed about the side effect of crystal violet dye. It's bad for eyes, skin, and for digestive system, brain, eyes. It's carcinogenic. This is the structure of crystal violet dye. Now, the adsorbent was developed by drying the unused part of the plant, dried, and after cleaning, cleaning, it was dried and grinded in a mixer. Its powder was sieved to 200 mesh size and it was used as such for removal of dyes. The material was characterized by FTIR and SEM. Here we have shown the FTIR and SEM images.
मीटिंग में हाँ मैंने पिछली बार एक बार किया था ना ये
These are the BADS adsorption study
नाम दे दिया था नेशनल
showing
सेमिनार ऑन
the effect of concentration, effect of temperature. You can see with increase in temperature, removal increases. Effect of dose, again, on increasing the dose, removal efficiency increases and finally it become almost constant. Here we can see that pH 8 is the ideal pH for maximum removal of the dye. These are the adsorption Friendlich, Langmuir, and Temkin, showing the Friendlich is best fitted one. Hill, non-linear Hill isotherm was also a good fit. These are the kinetic study plots showing first, pseudo second, and intraparticle. Here we can see that intraparticle is the best fitted isotherm. Kinetic model. We have evaluated thermodynamic parameters like delta H, delta S, and delta G, indicating the process. These values indicate the process is spontaneous in nature. And these are the breakthrough curve obtained by column, indicating a very good removal take place in 300 minutes. Again, this material can be reused. Initially, the removal efficiency was more than 90%, and after 4 cycles, it was more than 50%. It can be repeatedly used again and again. This table is showing the comparison of this material with some other adsorbent for removal of crystal violet dye. So you can see in the present study, the removal was 219.4 milligram per gram, which is highest among the reported values in the literature. Our material is very efficient for removal of crystal violet dye. So These are the conclusion. It is a very efficient material. We have studied effect of contact time, dye concentration, dose, pH, and temperature. And optimal pH was 8, up to 96% removal at 40 ppm concentration. And adsorption equilibrium was best fit using Friendlich and Hill isotherm model. Kinetic study suggests that process is endothermic in nature, and it is best described by intraparticle. It fits pseudo-second order model indicating chemisorption, involvement of chemisorption in the removal process. Adsorption is spontaneous and favored at higher temperature. This conclusion can be drawn using the thermodynamic parameters calculated from the process, and the column studies showed that adsorption is capable of efficiently removing 50 milligram per liter of crystal violet within a few hours, indicating it's a potential material for industrial application. The aerial waste serve as a cost effective because it's totally the waste material which is non-edible, stem and other unused part, efficient, it is cost effective, economical, efficient and sustainable adsorbent. Now the next study we are going to discuss is removal of eosin dye using chemically activated curcuma cassia agricultural waste. Curcuma cassia is also known as black turmeric, is a medicinal plant indigenous in Asia. It's member of Gingerbaceae family. Its rhizome are used for various medicinal purposes, but its aerial part has no commercial or medicinal value. So we have explored that part. This dye causes skin dermatitis, allergic reaction. It is carcinogenic, mutagenic, demand, COD, and the quality of drinking water. Disrupt photosynthetic activity in plants. It is harmful for aquatic ecosystem. Again, we have developed the material as was developed in previous case. The developed material. Here, the developed material means powdered material was treated with acid. And it was found that acid-treated waste is more efficient. Here we have conducted the study on untreated waste material powder as well as acid-treated waste material. This graph is showing IR spectra of untreated, acidic treated curcuma cassia waste and the IR of waste after adsorption of dye. The blue color is showing the after adsorption of eosin. These are the SAM images of treated curcuma cassia before adsorption. You can see various pores and voids are present in first image, while in second one, due to dye adsorption, most of them are filled. This is SAM image after adsorption of dye. In this slide, we have shown various mechanisms like electrostatic attraction, electrostatic repulsion, pore and surface filling, and hydrogen bonding used for the adsorption process. Here you can see the effect of concentration for both. Black color line is showing for untreated waste and red color is showing the treated waste. You can see the effect of contact time, effect of dose. In all cases, you can see that treated one has better efficiency for removal. This one is, middle one is effect of temperature. Again, we can see the with temperature, removal efficiency is increasing, and which is greater in case of treated, acid-treated curcuma case. Again, we can see the effect of pH. Here it was observed that at pH 3, lower pH means acidic medium is favorable. It favored the removal of dye. These are the adsorption isotherm plotted. Temkin, Langmuir, and Freundlich. And you can see that the highest value of R square is for Freundlich adsorption isotherm. Now, these are the plots for kinetic modeling, pseudo first order, pseudo second order, and film diffusion model. Again, you can see that value of R square is maximum for pseudo second order. Means it is best fit for the removal process. And thermodynamic parameters for both the adsorbent were also calculated and reported in this table. These are the column studies for treated curcuma cassia waste, showing a good removal, and the material worked for 600 minutes, means 10 hours. It was efficiently removing the dyes. The material can be reused up to 4 cycles, showing more than 50% removal efficiency. So we can conclude that it is a very good candidate for dye removal process. And the maximum removal can be attained at pH 3. Another work I'm going to share is of using a metal organic framework for removal of methylene blue dye from industrial waste. Here the iron BDC MOF was prepared at room temperature using solvothermal method. Very simple scheme shown in this slide. And it was characterized using XRD. It was found to be monoclinic with the space group E121 by C1. And when the dye solution, dye containing crystal oil, methylene blue, was treated with this synthesized MOF, the dye has been removed, as is shown in these absorption spectra of different dye concentration before and after adsorption. This slide is showing the effect of concentration, contact time, dose. You can see with time, removal increases and equilibrium is attained around 24 hours. As we increase the amount of metal organic framework, the removal efficiency, removal percentage increases. And maximum removal was observed at basic pH. Again, with temperature, the removal percentage increases. In this case, it was observed that the positive value of S indicate that increase in randomness is observed. So the process is spontaneous in nature. Positive value of delta H indicate endothermic process of adsorption. Delta H is higher than 40 kilojoule per mole in this case. So indicate the process take place via chemisorption. Negative value of delta G indicate the process is spontaneous. These are the data of column study. You can see that column was run for up to 300 minutes, showing a good removal efficiency. Another system which I'm going to describe is enhanced removal of methylene blue. Here we have taken iron BDC MOF. If we take cobalt dope iron BDC MOF, then increase of several folds has been observed. In this experiment, we have taken iron and cobalt salt in the ratio of 3:1, and rest of the process was similar. These are the characterization result, IR, XRD of the doped MOF, and we have recorded semi-DS indicated that successfully doping of cobalt has taken place. These are the FE-SEM image showing that cobalt has been doped successfully. This is the TEM image. Again, you can see the removal efficiency has increased several times while we studied the effect of concentration. First graph is showing dye removal in terms of percentage, and second graph is showing in terms of Q, in milligram per gram. This curve is showing the effect of dose. You can see with increasing the amount of metal organic framework, removal increases. On increasing the temperature, removal efficiency increases. If we talk about the pH, maximum removal was observed at pH 4. These are the Freundlich, Langmuir, isotherm. These are the kinetic models showing pseudo second order is better fit. Interparticle diffusion is also a good fit, showing pseudo second order is the best fit and governing the removal process. These are the values of thermodynamic parameter. So you can see delta H and delta S both are positive. So positive delta S indicate the increase in randomness absorption. Value of delta H is positive, indicating endothermic process. Negative value of delta G indicate the removal process is spontaneous in nature. And value of delta G decreases with increasing temperature, indicating that absorption is favorable at higher temperature. This is the column plot showing that good removal take place and column was exhausted in 70 minutes. Here, the value of Q is much higher than the previous case. And it was observed to be reused with more than 50% removal efficiency up to 6 cycles. So we can conclude that mixed metal MOF, they are better for removal of methylene blue dye in this particular case. And the synthesized MOF can be explored for removal of other pollutants like heavy metal, other organic waste generated from various industries. And similarly, you can work with minimum resources. You can start your research with minimum resources. Thank you. Thank you very much.
Thank you, ma'am. Thank you so much, Professor Charu Arora ma'am, for sharing such a valuable, informative insights on innovative wastewater treatment solution and various dye removal techniques. Thank you so much, ma'am. Now,
Thank you.
we open the floor on questions and interaction with our keynote speaker, respected Dr. Charu Arora ma'am. Please ask anyone questions.
Hello, ma'am. Am I audible, ma'am?
Yes.
Yeah.
Ma'am, actually, I belong to organic chemistry background, so I'm very curious about metal organic framework, and there is
Yeah.
the organic linkers, right? So,
Yeah.
what are the basic or structural condition for organic linkers in the formation of a metal organic framework?
They possess some functional group, like we have taken benzene dicarboxylic acid. So COOH group, NH2 group, such type of functionalities can be used as linker.
Is there any requirement of position of functional group like in ortho, meta, para? Position of functional group in benzene ring?
You can try with all, and you can obtain different the metal organic framework with different pore size and different properties. You can try all. There is no such.
Yeah, I got it, ma'am. Second one, ma'am. This metal organic framework are interesting molecules. So, what can be the challenges in scaling up metal organic framework synthesis in industrial applications? What can be the challenges?
Some of these are unstable. Some of these are moisture sensitive. So we can adopt various strategies to stabilize them. That is one challenge. And
Yes, thank you. Thank you.
some of if they are synthesized, solvothermal method is very economical, but some other methods, they are costly ones. For example, use of autoclaves, etc.
Any more questions? Any more questions?
Thank you so much, ma'am.
Thank you.
Ma'am, I have one question in mind. In a day
Yeah.
by day, we suffer from the number of polluted areas, and we see the industrial waste material from the our cities. So, can we prepare any absorbent material from the natural sources or for the absorption of domestic waste water, or any organic pollutant from the industrial waste, ma'am?
Yeah, a lot of research work is going on use of natural adsorbent. We have also discussed uh, three natural adsorbent like waste of Chinopodium album, waste of Curcuma cassia, and treated waste of Curcuma cassia. So such waste material can be explored for removal of domestic waste and other polluted bodies.
Yes, yes. Thank you. Thank you.
Thank you. I have one question, ma'am.
Yeah. Okay.
Metal organic framework and geolite synthesis means metal organic synthesis and
You are not
geolite
audible.
synthesis.
Hello.
Yes.
You are
Yes.
not audible. Madam, you are
Hello.
not audible.
Are you audible, ma'am, now?
Yeah, now you are audible. But again, voice has gone.
Or a different?
Hello. Can you write your
Geolite
question?
synthesis and
Yeah.
Okay, I will ask you in chat box.
Okay.
With it.
Hello.
Hello.
Start करो मैडम बोलो थे ना मैडम बोलो थे
Yeah, I got your question. You are working on organic luminescence. You want to synthesize European-based material using 8HQ for red emissions. Yeah, you can try using various synthetic methodologies and explore these compound for your applications. There are various other method of synthesis. You can explore.
Thank you so much.
Any other question or query?
Thank you.
The sessions.
Information of the department.
Professor Aruna
Okay,
ma'am,
ma'am. Thank you.
it was a very wonderful session, and I think there are no any question ahead. So I think the session was very informative, and audience might have enjoyed the session. So we formally thank you, ma'am, for delivering this.
Thank you, sir. Thank you for giving me the opportunity. Thank you very much.
Over to you,
Thank you, ma'am.
Thank you. Thank you, ma'am. Thank you so much, ma'am.
Thank you.
Respected Dr. Vijay, Professor, I to introduce our second session keynote speaker, I invited respected Dr. Pankaj Mishra, sir.
Thank you, ma'am.
Doctor.
Good morning, Tangri sir.
Good morning, sir.
Good morning.
It's our very much privilege to introduce my teacher. I have completed my master from Department of Chemistry at Nagpur Institute. After completion of their post graduation, after next year, Tangre sir joined the department. But in my whole research journey, we had some good communication with Tangre sir. So I personally know Dr. Vijay Tangre sir. He's very interesting personality with so much research knowledge, and his specialization, particularly in irreversible thermodynamics, is it's very very commendable, and it's very good. Okay. So today we have with us our second speaker, esteemed guest speaker, Dr. V. Sir. Dr. Vijay Tangade sir hold a position of assistant professor in the Department of Chemistry, RTM Nagpur, University Nagpur, and currently he's the chairman and board of studies in applied science and humanities, RTM Nagpur, University Nagpur, and he acted as a nodal officer, Mahadnandip, Government of Maharashtra, also assistant coordinator at IGNOU Center, RTM NU, and his qualification is MSc PhD in chemistry with research area particularly irreversible thermodynamics, and he has received grants from various funding agencies. Particularly, I will talk about DST PURSC grant project of 11.42 crores, and again there are some minor projects funded by UGC. He has a professional experience of 16 years, out of which 6 years at UG level and 10 years for PG level. Currently working at PGTD Chemistry RTM NU, and 1.5 year industrial experience. He has good number of publications, near about 50 research publications so far, and he has also 40 publications in conferences, and more than 50 seminar workshops and conferences attended by Dr. Vijay Tangade sir. And he is the author of 6 books, and he has visited globally, like in Greece in 2013 and 2014. His area of interest is irreversible thermodynamics, solution thermodynamics, and hadronic chemistry. Currently, 5 research students have awarded PhD under his able guidance, and currently 4 students are pursuing their research studies under his able guidance, and he has lot many honors and recognition. So if I try to read one and all the achievements, then it will take lots of time. So at the last, I would like to say that he's been awarded by best paper, best presentation award in international conferences. So there are 4 conferences where sir has got best presentation award. With this brief, informative, and very good introduction, I call Dr. Vijay Tangade sir to deliver presentation on the topic role of chemistry in sustainable development and challenges. Over to you, sir.
Yes, thank you, Dr. Pankaj, for this wonderful introduction. And I do not know really how much I worth of it, but then I'll try to justify my role today, because the field in which I work is actually thermodynamics, and I'll try to justify my role in today's theme of innovative and sustainable development goals. Let us see where we stand. Let me give the privilege of sharing my. Please share rights to share my slide.
Yeah, yes. Your co-host now, you can share your slide. Now you can share your slide.
Yes. Yeah, I hope my screen is visible.
Yes, sir. Clearly visible.
Yes, and is my audio is clear? I can hear echo from background. Is it okay?
Yes, sir.
Yeah. Okay. So at the outset, let me thank to the organizers for giving me this opportunity to interact with all of you, elegant gathering on this particular topic of chemistry for innovation and sustainable development, CISD 2025. And Dr. Mahesh, I'm particularly thankful to you for giving me this opportunity, because when Dr. Mahesh asked me as such, I do not have much of the research in sustainable development chemistry. But then he said, sir, you can elaborate some of the general topic. So it's quite obvious that I will not be speaking on much on the research area, my personal research area. However, the generalized aspects where chemistry is playing role in sustainable development and the other challenges. So, thank you all, and let us start with this lecture. I will feel honored if some of you have any query. You can interrupt me at any time, and you can ask your queries so that it can be interactive session as well. Okay. So, when I thought of this topic, sustainable role of chemistry in sustainable development, so the first thing came to my mind was what is sustainable development for which we all are working right now. Currently, we are all working towards from uh, developing country to developed country. So, from that point of view, we must understand the meaning of sustainable development. So, Brundtland's report in 1987, which means a simple line that whatever we do here, if it is for meeting the needs of the present without compromising the ability of future generations to meet their own needs, that is what is the sustainable development. That means as a current generation, if we do not consume whatever natural resources which are available to us, and we keep them and we nourish them for the coming generations, so that development would be calling as would that would we will call as sustainable development. Irrespective of, I mean, we all have witnessed this era as a whole, and we have seen the drastic change from the fossil fuel to the renewable energy sources like solar energy, wind energy, hydrothermal energy, geothermal energy, and whatnot. And tell me any area where chemistry is not playing role. That way, the topic, when Dr. Mahesh said, it became very easier for me when I thought of the area which is not belonging to chemistry. Everywhere there is a chemistry. Right from recycling, reusing, and utilizing the things to the, I mean, planting the trees, to using the green fuels, biodiesels, and whatnot. So, sustainable development, when we say sustainable development, the role of chemistry has to play a significant role in the scientific, I mean, domain. So we all are part, being chemist, we all should feel proud that we all have our parts to play at one or other nook and corner of each of the scientific domain areas. So you cannot limit yourself to one or other area. When I say the role of chemistry and when I try to relate my role of chemistry with the sustainable development goals of UN, so there are basically almost around 15 major sustainable development goals we called as SDGs, out of which two main goals are clean energy and clean water. Only if we can maintain this, the majority of the problems are going to get suffice for. And as a chemist, we can understand matter, we can understand the transformation of the resources, we can understand their efficiency, we can design new material, we understand their processes, and we can thereby utilize the material so that to have the minimal of the best. As a chemist, we can address almost all the SDGs which UN has given. And therefore, I say chemistry can play a central role in the sustainable development. As such, the development goals, sustainable development goals contains very generic terms. It indicates no poverty, zero hunger, clean water, quality education, gender equality, social equality, justice, peace, and whatnot. And as a chemist, we have a very important role to play in it. Okay. But I would like to, ask you, if my voice is not clear or somewhere it is breaking, please let me know. Otherwise, I'll just go on keeping mumming this, and it will not be useful then. Okay. I hope I am very clearly audible.
Yes, yes.
Yeah. Okay. Thank you. So the first and foremost thing that came to my mind was obviously green chemistry. As a chemist, we all understand what the chemistry is and what the role of green chemistry is. Many of you are as working as a teacher, faculty somewhere, doing research somewhere. Many of you are excelling in your research to a great extent, and therefore I should not mentor you on the green chemistry topic, because this is not my cup of tea. However, when I thought of the role of chemistry in sustainable development, I could not resist myself in from talking about green chemistry, because without green chemistry, as a chemist, I cannot talk about the sustainable development goals. And therefore, the green chemistry, if I try to understand from a general perspective for a layman, this green chemistry is a utilization of some set of principles which, in 1995, we all have gained. And there are approximately 12 principles that are utilized to, or that are based on some fundamental principles of reduce or eliminates the use of generation of hazardous substances in the design, manufacture, and application of chemical products. So to start with, we can start as a chemist, we can start with such a reactions which are talking about atom economy. We can slowly begin to spread the wings by using the renewable feedstocks, which can be replenished over the time, and which we can use again and again without thinking about finishing or exhausting their stocks. And later, at one point or other, our chemistry can help us in gaining in this competition. We can stand as a chemist. There can be several solutions. We can have a safer solvents. Like earlier, people used to talk from the hazardous waste. We came to know about ionic liquids, wherein we talk about atom economy. Now people are talking about deep eutectic solvents. Some of the work we also have done, I will show you in one of the slides. And therefore, by thinking in this aspect, we can really utilize the knowledge of chemistry. We can definitely use the catalyst for the clean chemistry and sustainability development. Basically, what I mean is, even for the synthesis of catalyst and enhancing their efficiencies, we need several processes wherein, the designing and developing of catalysis or synthesizing catalyst, we can use some safer solvents, and then those catalysts can be used so that some environmental load can be depreciated. So this way we can lead to less hazardous derivative, and this way we can make the world more Kupatan life that way. This is a just general introduction to what is green chemistry, because all the 12 principles, they talk about the sustainable development. And long back people have thought of it and designed this principle, although all of them, they are on ideal lines. But let me change my pointer. Yes, I hope you can see the pointer now. So there are these principles, and all of these principles, they are meant for the sustainable development. Although all of them, they are describing the ideology or on the ideal track. But then if we put forward at least a step towards each of them, I guess we can provide the relief to the surrounding as a chemist. Atom economy is one of the important aspects as a chemist we can deal with, because we can reduce the hazardous byproducts which we are releasing. Less hazardous synthesis processes we can develop as a chemist. We know several processes like in fertilizers, like in material synthesis, wherein we produce a lot of hazardous material, and those materials go into the atmosphere. So we can focus on reducing the non-toxic substances. Safer chemicals we can use, safer solvents we can use, energy efficiency we also can observe, and we can make aware of our generations for the energy efficiency. Renewable feedstocks we can have, we can utilize renewable raw materials, we can reduce the derivatives, use the better catalyst and derive the catalyzed based processes. We can design and the products which are used for breakdown of the harmless substances. Real-time analysis also we can do, so that AI can be used for or the data analysis can be done in that field. And that way, the chemistry or green chemistry can have the important role for playing role in sustainable development. This is one of the important aspect I should talk about when I'm talking about sustainable development. Preventing waste is the need of an hour that we should teach the current generation, because as a teacher, we have the better generation to train about, and therefore we have got a better responsibility or bigger responsibility as a teacher, irrespective of your subject. So to prevent the waste than to treat or clean up is the first and foremost thing I should say here. We will go with the next steps wherein we can use the knowledge of chemistry, but then without using the knowledge of chemistry, we all can help to sustainable development by following this simple step. So this is one kind of message that one of the principle of the green chemistry gives us. So let's waste less. These are a few slides wherein chemists play an important role. My colleague Professor Karde has given me these important slides, and you can see the classic route of some reactions, and then how chemists can play a role, because my topic justifies this particular part, and that role of chemistry in sustainable development and the challenges. So we will see what the challenges are, but then these are some of the relevant slides I'm going to show here. There, as a chemist, we can justify our role in the UN Sustainable Development Goals, SDGs, for that. If you look at the classical route for hydroquinone, if you look the overall reaction, look in red, these are all the waste byproducts or side products that usually as a chemist in our lab we produce. And as a important material of hydroquinone, we need this hydroquinone at many places. So this is particularly useful in intermediate in synthesis of polymeric materials. So you know polymeric material synthesis is a big branch now, and you can imagine at what scale this material must be getting synthesized at a local level. So if I do not follow the atom economy as a chemist, and if I do not care about the sustainable development, what effect I am doing to the environment, this table can tell you. See, the carbon content which are utilized in this particular reaction is utilized to 100% for the final product. So no carbon is coming out as the side product. As such, that is not a problem. However, if you look at the other material, hydrogen, oxygen, manganese, sulfur, iron, out of which hydrogen and oxygen, they are actually playing role up to 33% and 13% respectively. However, manganese, sulfur and iron, they are actually working as a catalyst in the reaction, and they are getting utilized, and they are creating, we are actually creating the byproduct, and those are going into drain. So if you look at the atom economy, the account of atoms we are using is not good in this particular reaction. Look this way of green synthesis. I mean atom economy on the lines of green chemistry. If I look at it, bisphenol is getting converted into, para-isopropenyl phenol and then phenol. So along with para-isopropenyl phenol, I have phenol, and then that is treated with the hydrogen peroxide to get the hydroquinone or the catechol that is again used for some of the polymeric material. The remaining byproduct is acetone, and that can be using that acetone again. The first step byproduct, that is phenol, can be treated to create a bisphenol, and that this bisphenol is again the original starting material. So what am I doing in this reaction? This is a wonderful reaction, which we call it as the Upjohn route to hydroquinone. I'm sorry. So this Upjohn rule is, just a minute. Is a starting material, and in response to that, while preparing my final product, I am getting back my original bisphenol or starting material in some fraction. So this is a kind of feedback reaction. The feedback is given by the original reaction and my reaction is getting supported, and atom economy is up to 100%. So this way I have to use the knowledge of chemistry in bringing the sustainable development. So if I develop such kind of reactions in the industry, so my industry will be environmentally sustainable, and I am one of the important aspect of SDGs. Look again, the reaction at the red, which is the epoxidation of alkene using peroxy acids. If you look at the atom economy, it is 100%. Whatever you are using is getting converted into product 100%, no side product. So exactly in toto, the principle can be followed. Although there are some exceptions while going into industry, there are other maintenance and other aspect. When I do life cycle analysis, there are machine running, usages of water, all these aspects come into picture. CO2 expel also come into picture. I will talk little later about that. This is one of the, again, important reaction, classic route to ibuprofen. And as an organic chemist or medicinal chemistry student, many of you may be knowing this. Look at the first reaction wherein the atom economy is following, and the number of byproducts those are getting generated. And look at the greener way of ibuprofen, and wherein the atom economy is much higher, wherein the catalysis reaction is followed. Anyways, I will not go into the organic chemistry or mechanism part. That is not my cup of tea and not my field. But then these are few reactions wherein we can utilize our expertise as a chemist to develop the chemistry. One of such reaction is again this polycarbonate synthesis using phosgene gas, wherein phosgene gas is very dangerous. And without phosgene gas, I can utilize the same reaction with the one having a solid state process. So solid state synthesis are also one of the emerging trends in chemistry we can see. And this process is by Komiya et al. And this is particularly given in literature. The other aspect I can talk about is the safer solvents. Many a time solvent which are used in a reaction that are not recoverable up to 100%. And much of the solvent goes into waste, and that has to be treated to our STPs and ETPs. So that also I need to keep in mind. Many a times we can actually carry out some reactions which are known as solventless reaction, as we have seen previously also. So we can use this. This is one of the important aspect. I'm not going into all 12 principles, the 3 to 4 principles which talks about really sustainable development, which contributes to the sustainable development that I'm talking about. Use of renewable feedstock is another important aspect. As a chemist, I must know. Bioethanol, we all are hearing today. Biodiesel are again a burning topic. And now the agricultural content for agricultural raw material can be developed for the sustainability, which is deriving towards the sustainable goal development, sustainable development goals. So many of the aspects are given. If I go on talking about the biocatalysis and biofuels, we can have one complete lecture. Those who are doing particularly research in biocatalysis and biofuels, they can particularly deal about how we can utilize our backyard for the generation of algae that can make money for you out of your backyard by generating algae, or non-edible oil crops, or करडईच्या बिया असतात, that also we can do. Then the industrial byproducts we can utilize. Sugar cane also we can utilize for edible oil crops. We can utilize corn crops. We can utilize many things we can utilize for generating the renewable feedstock or some kind of natural agricultural waste material that can be utilized for the fuel generation. Anything specifically want to discuss? Please let me know. I'll be happy to discuss. Otherwise, I'll just go on speaking only one way. Feel free. This is one of the important aspect of how we can convert the algae oil and agricultural waste material into the useful material. So renewable oil production process can actually reduce in comparison of fossil fuel. We can reduce 95% of the CO2 output, which contributes to the greenhouse gas. These are various aspects. This is one of the recent studies in which we have ventured into. And if you look, I am basically a theoretical thermodynamicist, which who has entered into experimental studies a few years back, and we were doing thermodynamics within normal studies. But later we found found very interesting topic of synthesizing deep eutectic solvents. And we have ventured, collaborated with some other group from LIT, and then we could generate an interesting study. One of the recent papers tells you about this, that is towards green synthesis of magnetite nanoparticles, a comparative life cycle analysis of deep eutectic solvent based synthesis of magnetite nanoparticle and conventional method. What we basically did here, we have tried to develop, synthesize and very novel deep eutectic solvents of choline chloride along with chloroacetic acid. This is what we have taken. So what are deep eutectic solvents? Deep eutectic solvents are basically the mixture of hydrogen bond donor and hydrogen bond acceptor. When a particular suitable hydrogen bond donor and acceptor, they are mixed at room temperature, they are solid individually, but when we mix them, there is a lowering in boiling point, melting point, and they become a liquid, clear liquid at the room temperature. Sometimes we need to heat it little bit, but then when we mix at room temperature, they mix up and they create, they produces a clear solvent at room temperature. Now, by mixing two solids, we create the solution by lowering of their melting point. So this is a phase transition thermodynamics we are studying since long. And as a thermodynamicist, if you see, so depression in melting point, depression in boiling point, these phenomena are not new to us. So if you look at the phase diagram, it gives you a very interesting study. It gives you very interesting study. So in such case, what we have taken, but what we have done, we have prepared the deep eutectic solvent, and based on deep eutectic solvent, we have tried to synthesize the normal nanoparticle, ferrite nanoparticle, which we call it as a magnetite. Now you will say magnetite are not new. Nanoparticle have some, many people have prepared by solvothermal method, by Sol-Gel method, by co-precipitation method. There are n number of methods, no doubt about that. So we tried testing our DES for synthesizing this magnetite nanoparticle. And to our surprise, we have seen these nanoparticles, which we called as magnetite, we could synthesize these magnetite nanoparticle with ease without putting into any external efforts. Very easily we could synthesize them, and then we have seen the size of this nanoparticle came down up to 1.3 nanometers. So, at such a low level of crystallization, we could synthesize those nanoparticle, and then we tried to use it in different processes. So we have used in Bijnali reactions and all those things we tried to do. However, in the meanwhile, we came to know what's different in our synthesis. So we went to some technology aspects, and then we find what technologies does whenever a new process is being designed. So a technologist actually focuses on what environmental load you have given while synthesizing this particle, these material. So we have carried out the life cycle analysis of these DES synthesis and magnetite nanoparticle synthesis. So we have compared the conventional methods like solvothermal method, Sol-Gel method, co-precipitation method, thermal methods, and we have counted out the thermal loads and the environmental impact of all those conventional methods on the environment, and then simultaneously we compared the environmental load by the process which we have followed. Interestingly, we have reduced up to 60% of the environmental load than other conventional methods, and there it was a success. And therefore we thought it is one of the important component of our laboratory, wherein we could contribute to the sustainable development, although the method and the material is common, but the way we have synthesized using the deputative solvent is again the innovative. And that way now the deputative solvent is playing the chemistry aspect. So I thought sharing this study with you is that way. What else comes into or should come into our lecture when I talk about sustainable development goals as a chemist? So where chemistry is playing a role. So whenever I say sustainable development, I must observe for sustainable energy solutions. Now, as I said right from beginning, now we are now shifting our focus from fossil fuels to renewable sources. So the majorly there are three categories we are now seeing in the market. What the shift is being getting. Solar cell is not new to us. Hydrogen economy is not new to us. Batteries is not new to us. So as a chemist, if you see everywhere, chemist has to play a significant role. In solar cells, day by day, new technology is being derived and developed. Perovskite-based solar cells with high efficiency are being developed. And even if you see daily the news items, the solar cells are routinely being improvised and getting developed. Hydrogen economy, now again you see, we usually enjoy watching Honorable Minister Nitinji Gadkari in sitting in hydrogen-powered car and bus, and all those technologies being adapted routinely. Many other countries are getting shifted into the hydrogen economy. So as a chemist, I have an opportunity to design and develop the catalysts for water splitting that are being researched to produce the hydrogen fuel. Batteries, again, recently while giving my introduction, Dr. Pankaj said, discussed about the DST PERS project for particularly to the university. It has been sanctioned as a group to us. So there are, I mean, three departments of the university wherein we are working together. And in this particular project, one of the major component is given on this sustainable energy solutions and sustainable development goals, wherein we will be talking about the batteries. So one of the important aspect in the project is sodium ion batteries. So of course, lithium ion batteries has got its own potential and futures, but then sodium ion batteries are really researched as eco-friendly alternatives. And fortunately, you will be witnessing in the coming months, very soon in the university, very advanced instrumentation for working on all such facilities currently is being established and developed at the university campus. And I guess let us hope for the best that we'll be able to come out as a university with the best possible solutions. What are as a country we are doing? So if you know the India's push for the solar parks, so we are very familiar because everybody of us now is focusing on the solar panels. So बहुत सारे घरों पे आपने अभी solar panels देखे होंगे. Out of from the missions of National Solar Mission, wherein the Jawaharlal Nehru National Solar Mission 2010 was started earlier, and now it has been escalated, and it is expected to raise to 280 gigawatt by 2030. This is the target. So currently the 100 gigawatt capacity by 2022 it was, and now it has been raised, looking at its potential to 280 gigawatts by 2030. So as we know, India is one of the world's largest solar energy producers. The only thing is we as a chemist has to play a role in designing and developing of the more and more efficient materials. The solar park development also is one of the aspect wherein you can see the large-scale grids connected installations in Rajasthan that has been established currently worth 2,245 megawatt capacity, world's largest Bhadla solar plant park is being developed. Pavagad is again a solar park of 2050 megawatt. So definitely chemistry has a important role to play in such developments. Photovoltaic materials like silicon, cadmium, beryllium, perovskites, anti-reflecting coatings for increasing the efficiency, non-sticking material development, battery storage, transformers, lithium-ion, sodium-ion batteries to source solar power. All these are the aspects wherein as a chemist, world is looking at us as a chemist. Green chemistry in solar is again what we are talking about is in sequence. So we should shift towards the perovskite solar cells, wherein the efficiency is more. And in that direction, we need to proceed. Use of lead-free perovskites is the need of a time to reduce the toxicity. Development of recyclable solar panels to address the end of life waste. So we should deal towards zero waste processes as a chemist. Like solar, the India's push for EV is another aspect we must talk about as a chemist when we talk about the role of chemistry in development of sustainable. Government has taken his National Electric Mobility Mission Plan, NEMMP, and FAME India scheme. We all know this is a faster adoption and manufacturing of hybrid and electric vehicle, which we called as a FAME, which was launched 15 later. It was not very much effectful, but now it is very effectively working. So government has launched many schemes to incentivize for EV purchase and charging infrastructure development. Many big companies across the globe are very rapidly developing the network of charging stations. You must have witnessed on roads also when you are roaming. You must be watching the EVs, which are at the rate at which the EVs are increasing on road. So these are all things which are actually out of the efforts of governments through National Electric Mobility Mission Plan. Chemistry has a major role to play into it. As I said earlier, also batteries like lithium, cobalt, nickel, zinc, solid state batteries, and whatnot. Not only batteries, we need to work out on solvents which will give you more bandwidth or more potential windows. So, like as I said, DES has a greater potential to develop the electrolytic material with the greater potential window, and we can design and develop such hydrogen. I mean, as a chemist, we can design, we can find out the more and more pairs of hydrogen bond donor and acceptors, and irrespective of edible, non-edible, amino acids, lactic acids, or blah blah blah, whatever other things. So as a chemist, we have many things to do all permutation combinations, and we can one day we will find out definitely the solutions of which will give you the more potential window or dramatic potential window we may obtain. We can design and develop such catalyst. We can start utilizing the battery recycling using the metallurgy and pyrometallurgy. At this point, I would like to mention here that recently one of our good friend from the university department at Nagpur, is one of my good friend, and they could develop the good battery recycling manufacturing unit, battery recycling unit at MIDC Buttibori. And I have personally seen his efforts which has been taken. So they have now set up a plant at MIDC Buttibori, wherein they import, I mean, they actually get the waste mobile batteries and this computer UPS batteries, and they recycle it to generate the segregation of black mass and the other important minerals out of the waste battery. And you won't believe the output from the recycling of waste industry can give you to the multiple manifolds of the aspects can be given. So this is how as a chemist, I can play a role because I understand the nature of material and I understand their interaction with the material. So as a chemist, I have a potential to develop the methodologies to segregate. You may have some ideas to design some methodology to precipitate out some rare earth material which otherwise is being going waste into the waste batteries. So I have this opportunity. So as I said, solar parks, EV adoption, in whatever we do, everywhere a chemistry has a role to play in generating the high efficiency solar material, having the safe and high capacities battery, or the recycling technologies for the circular economy, because whatever we use from the environment, that is going to get exhaust. So unless I develop the recycling technology, I may not be getting the same product again and again from the nature. And even if I get, what will happen to the waste I am generating day by day? So I must now move towards the effective recyclable technologies. That is what is one of the important aspects we need to focus as a chemist. Again, the agriculture field is one of the important, agriculture and the fertilizer is one of the foremost and important of the topics, because what we are observing now, many a times you must be observing now, people say, "Arey, aaj ka food, it is contaminated with so much of fertilizers and poisonous material." Why it has happened? Because we tried to get more out of the less land. So we try to exaggerate the crop with the NPK fertilizers, either you say, or you say nitrate leaching, or you say eutrophication processes which we observe, or the greenhouse gases like N2O which are being released due to the manufacturing processes of such fertilizers. So it is a need of an hour to sustainably manage the nutrients of the soil. And therefore, the foremost thing is to have the sustainable fertilizer approach. So what should we do now? As a chemist, now the technology has developed, so we should shift our focus to the nano fertilizers. Nano urea is one of the important aspect or emerging fields that is being we are witnessing now. Slow release of nutrients and specific release of nutrients we can develop. Higher nutrient use efficiency we can have. Small doses where we can do biofertilizers, that way are more effective because they produces the lesser hazard to the nature. So rhizobium, azovector, and mycorrhiza are all the examples of biofertilizers. And the other aspect as a controlling fertilizer aspect is we need to have the controlled release of fertilizer, encapsulations or coating of sulfur or bio-based polymers that matches with the plant growth cycle. That also can be done with the help of biotechnology, biochemistry, and all those aspects we can have. Other important aspect is while designing these fertilizers, surface chemists play an important role, biochemists play important role, polymer chemists play important role, environmental chemists play important role. And you can see on this slide, I have given their roles in that a particular chemistry can play in designing and developing these kind of sustainable fertilizers. The most important aspect that we are currently worried of, where the globe is currently worried of, is water treatment and clean technology. If I talk about the statistics, 2 billion people worldwide lack access to safe drinking water. It's a big number. It may be industrialization, agricultural development, and natural contaminant like arsenic and fluoride that pollutes the water. But at the same time, chemistry can provide the innovative solution for the purification, pollutant removal, and sustainable wastewater use. What are the methods we can follow in laboratory? As the previous lecture I was listening for some time, that was an interesting lecture by madam. And in her lecture, she has shown some of the glimpses of her research, wherein she talked about the material she developed. Each of the terminology on the screen right now talks about such kind of methodologies. we can utilize our expertise as a chemist either by following the advanced oxidation process or photocatalysis process or nanomaterial and targeted pollutant removal process or membrane technology processes. We can use either or all for the removal of contaminant from the water. We can have the strong oxidants to degrade the toxic organic pollutants like dyes, pesticides, pharmaceuticals. For this, we have to do little experiments in our laboratory. Not from the point of view of getting only patents, not from the points of view of getting only publications, but to find out the real solutions. It may happen that in laboratory we may not produce the mimicking situations like in industry. So we should try and develop the collaborations with industry as a chemist, and then we can deal with such a real world samples so that we can give some kind of solutions. At our place, we have some groups those are working on the chitosan based biopolymers materials and their derived adsorbents, and they are now involved into good kind of research. Photocatalysis is another method wherein we can utilize the freely available sun energy in deriving such material for the water treatment. Membrane technology for providing clean and safe water to the unprivileged places or people. Nanomaterial for targeted pollutant removal is one of the emerging field wherein we can utilize our expertise. There can be several challenges. However, as a process of being the developed country from the developing country, we have to overcome such challenges. Usually why do people fail to go for the unit process operations or what I can say, expanding the lab to industry solutions is because it involves high cost and it involves the energy requirements, it involves the advanced instrumentation. Scalability हमारे पास नहीं होती है, we cannot afford as a small institute. So nowadays government is coming along with many such programs. Do small experiments at our laboratories, at your laboratories, and then try to propose for the expansion of the method. And then we can really have the solution to such problems. The other important aspect is development of sustainable material and circular economy, because unless, as I said, circular economy and recyclability is one of the important field that as a chemist we all should understand, because there is a enormous potential wherein our students can be an entrepreneur in the methods. Like as I said, hydrometallurgy का example मैंने बताया how we can use the waste mobile battery into the useful industry, wherein all the small parts of the batteries can be utilized and extracted out into some useful material. We can have the biodegradable polymer material, hydrometallurgy using green solvents, geopolymers. Yes, we can actually use deep eutectic solvent like material or ionic liquid kind of material to dissolve battery components, and then we can segregate one by one with the knowledge of chemistry. Of course, there will be challenges like scaling up bioplastic production while keeping the costs low is one of the challenge. If efficient separation and recovery of metals in complex e-waste stream is another challenge. But then at the same time, we can have the help of chemistry to design and develop various deep eutectic solvent kind of materials wherein one material can be diversified material can be made solubilized into one of the component as a solvent. Because see, understand the greener way of deep eutectic solvent kind of material wherein you have all kind of approaches available, wherein hydrogen bond donor and acceptor kind of things are available, wherein two different polar ends are also available to get solubilized the material, and therefore such kind of e-waste can also be made solubilized and then segregated based on their solubility product. Physical chemistry again playing a very important role into it. So the circular economy solutions in chemistry mean designing material that biodegrades, recycling means safety, and replacing carbon intensive materials with the greener ones. This helps reduce pollution, save resources, and fight climate change. The important component of the sustainability development is again the pharmaceutical and health related. Why it is important? Because again, we know the role of pharmacy component in our routine life. So pharmacy industry, which has got a high value, and at the same time, the resource and waste intensive component is also very high. So many processes, they use toxic solvents like chloroform, dichloromethane, benzene, and they generate large amount of waste. So we also should try to generate such kind of methods and processes which leads to sustainable pharmaceutical methods, which talks about green synthesis, atom economy, safer solvents, biocatalysis. There are many examples of, as I have shown you some examples of greener way of synthesizing them. And the sustainable pharma practices can really helps us in having the green solvent synthesis. We have to analyze, or we have to do life cycle analysis of each of the process which we follow, as I have shown you in one of our paper recently, wherein we have done NCA, and we could find out what is the environmental impact, what is the load of water consumption, what is the role of CO2 emission, what is the role of environmental impact. All these aspects can be studied as a flow chemistry. Climate mitigation is one of the important aspect again in mitigating the sustainable development goals. So herein also chemistry play an important role. I will not go into detail because I am running out of the time. The time which has been given by Dr. Mahesh to me has already crossed. So I will just finish it in time. So carbon capture and storage, CCS, is again carbon CO2 sequestration is one of the important aspect which in our laboratories we are doing actually now. And we in the DST Pulse project, we are actually procuring very high-end instruments for the CO2 sequestration and studying the surface area analysis and pore volumes. Conversion of CO2 into fuels and chemicals is one of the important aspect, wherein cracking of hydrocarbons is important aspect, wherein we are again venturing into one of the NRI projects which recently has been sanctioned. Very soon it will be coming to the university departments. 10 faculties have received such grants. Now, greener refrigerants, and as a whole, for chemistry, there is a big picture to play an important role. So there are some case studies across the globe which has now been towards the direction of sustainable development goal of UN with 15-point agenda, wherein we are trying to convert the catalytic processes or pyrolysis processes, wherein we convert the plastic to fuel. The cement industry, in cement industry, we are now trying to give the more convenient geopolymers alternative to the cements. National Hydrogen Mission, as I told you, bioethanol blending norms of India, all of you know, E20 program, and the other shaping industry policies by following the strict norms and insisting the clear technologies. Of course, the bureaucracy plays the vital role in developing all those studies. My last slide on this particular topic is, although chemistry contributes to pollution, but to reach to cleaner resources and economic growth, the implementation of green chemistry gives you the bridge to satisfy these sustainable development goals. Thank you. Thank you so much, dear friends, for your patient listening. And I hope I have tried my best to justify my role as a chemist in defining the sustainable goal achievements. Thank you.
Thank you, sir. Thank you so much, sir, for your enlightening, informative session, sustainable chemistry and its future scope in chemistry also. Thank you so much, sir. Now we are open the floor of question, answer and interaction. I know that everyone can interested to interact the sir, interacted respected Tangre sir to asking the questions. Everyone can ask the question one by one and unmute yourself.
Thank you so much, sir. Sir Mahesh here.
Yes.
I want one suggestion. I am not asking a question firstly.
Yes.
Sir, I like the solvent-less reactions in your slide we see.
Solid state
So
reactions
I
are
think it is a
there.
low-cost method. Yes. So can you increase the efficiency of product and how to separate the product from this solvent reactions, sir?
See, in not many cases this can be done, but then basically since we can talk about the oxides and the battery related materials, wherein we go up to high temperatures with the traditional reaction, we can mix two solids and then try to form the multiple fractional oxides that can be utilized in the battery materials.
Yes.
So this is one of the option. But then the other method, what I was talking about, is try and use various proportion of mixings of say new fascinating material like hydrogen bond donor acceptor kind of pair. I mean, earlier time people have studied theoretically the possibilities of phase transitions. But then nowadays you can try such multiple pairs and you can try finding the suitable solvent, greener solvent for you, wherein such materials which were earlier not solubilized because of the very harsh conditions of catalyst or requirement of catalyst, or otherwise we used to need the dangerous chemicals. We can avoid all such things and we can recycle the same safer solvent again and again for the same process, and we can get back what the material we have. So it's not very difficult that way, but then not all processes, but at least few of the processes can be done. Like I said hydroquinone and catechol. We can try replacing the polymeric reaction in the case.
Yes, yes, yes. Thank you. Thank you so
Sir, one question from my side.
Yes.
Actually, we were talking about use of biofertilizers in agricultural activities, and like urea at nano level, etc.
Yes.
So basically, problem is that all things are available, but people or farmers are not using all these fertilizers effectively at the farm. So what can be a better solution so that they can use these fertilizers or biofertilizers? Because people are continuously using conventional urea and pesticides. But no, these things are very interesting. Being a chemist, we have prepared these nano ureas, but their utilization is not up to the expectations. What can be the measures?
Yeah, I mean, see, Dr. Pankaj, I'm not an expert of the field, but then just as an exposure to the concerned field, I was a few days back. I was actually invited for delivering a lecture at drone science and cyber science in just recently started course in the university to address to the newly admitted students to the course. And while listening to one of the speaker there, we came to know very important aspect of delivering the drugs to the plant using drone, and especially such kind of innovative drugs, nano urea and other derivative drugs. Those can be very effectively utilized to deliver to the plants. And then I could come to know that it's actually the lack of awareness people have. With the advent of technology, I can put such a material to the plant which will not only give you the good crop yield, but it will enhance the soil capabilities as well for the future generations, which has been, actually it is used to replenishing the soil health along with the fertilizers. So biofertilizers is not only the about putting the fertilizers for the crop, but it is about the replenishing the soil along with the fertilizers like encapsulated material of sulfurs. Let it go into the soil. Encapsulated materials of nitrous oxides, let it go to the soils. So it will be delivered to the soil so as to increase, and that those materials are encapsulated with some polymeric material. So over the time, it will be getting disseminated to the soil at the table. It will reach to the table of the soil up to some depth, and so that the soil can be replenished over the period again for the future generation. So the idea I liked it so much. So as you said, I think it is the lack of awareness. As a chemist, how far we can do, but then as a society, we can make people aware of
Yeah,
using. I mean,
that's
administration also plays very important role.
important, all right.
Although I am
So
not an expert of the field, I'm sorry. I'm not able, if I'm not able to answer your question.
Yeah. It is out of yes, sir. I know, sir.
Yeah.
It was just a general question. Thank you, sir.
Yes.
Thank you.
Hello, sir. Tangle, sir.
Arre, sir, good afternoon. How are you, sir?
Yes, sir. Actually, I am the person from the mathematics field, and I am
Yes,
very
I
much
know, sir.
impressed and influenced by listening your entire session, sir. It's the first day after long period I just know about the green chemistry, and as a person of mathematics, the question is in my mind is going, in my mind a question is going is that how can I contribute to the field of chemistry as a person of mathematics, how I can contribute for the sustainable development of the field, because my subject is having a limited applications, and your green chemistry having a large number of applications in the society, and I really want to contribute and do something mathematical type modeling by considering the subject of green chemistry. Please guide us about that, sir.
Sir, first of all, I congratulate to you, and let me tell you that you have a very major role to play in chemistry. You also know that I belong to theoretical chemistry, and I did all my PhD in mathematics. Almost my thesis is mathematical. Hardly there is a chemistry. I mean, the referees those who came to evaluate my thesis, they were asking where is chemistry. So jokes apart, let me tell you that nowadays the data which we are dealing with, although I'm also dealing with solution thermodynamics, and the data which we are now dealing, we need at every place the person from the mathematical background. And mathematics plays a vital role in keeping the data and the statistics. Now, whatever we are doing in our lab, it's mathematical modeling, generation of the patterns, their behavior, everything is done mathematically. So all the predictions, I mean, you can witness, you can vouch it vouch it betterly than me, that how mathematical data has been, we are as a society, we are using since long. I mean, COVID, अगर मैथमेटिक्स नहीं होता तो कोविड से डील करना पॉसिबल नहीं था. कितने भी साइंटिस्ट हो जाते, कितने भी बायोकेमिस्ट हो जाते, कितने माइक्रोबायोलॉजिस्ट हो जाते, कितने केमिस्ट हो जाते. So, sir, definitely whatever is the science, mathematics is a language of science that can talk about, and therefore I guess your role is everywhere. I mean, the person will be luckier to whom with whom you will be collaborating.
Thank you so much for the inspiring words, sir. Definitely, I will come to meet and just start something new by taking that field.
Surely, sir, surely welcome, and I'll be waiting for that. Yes.
Anyone can ask the question. Now it's time to vote of thanks. I formally vote of thanks and present. It is my proud privilege to deliver the vote of thanks on behalf of the Department of Chemistry, Shri Lemdev Patil Mahavidyalaya Mandal, and the entire organizing team of this one-day national seminar on chemistry and innovation and sustainable development. First and foremost, I extend my heartfelt gratitude to our keynote speaker, respected Dr. Charu Arora ma'am, Professor and Head of Department Chemistry, Guru Ghasidas University, as well as respected Dr. Vijay Tangde sir, Assistant Professor, Department of RTM Nagpur University, Nagpur, for their insightful, thoughtful, provoking, and impactful sessions. Seminar. Thank you so much, sir and ma'am. I also thanks respected Dr. Navneet Kumar Lamba, Principal Shri Lemdev Patil Mahavidyalaya Mandal, the warm welcome address. And I also thanks to respected Dr. Pankaj Mishram sir for his valuable introductory remark and speaker introductions. I also thanks to Dr. Mahesh Gaidene sir for giving us speaker introduction and ensure that this event runs smoothly. I especially appreciate goes to the organizing committee members, technical team, dear participants, and our students who have joined us today's wonderful seminar. Thank you so much, all and all.
Thank you so much, sir.
Thank you, sir. Thank you, Lamba sir. Thank you very much for inviting me. Dr. Mahesh, thank you. Dr. Pankaj, thank you. Dr.
Thank you,
Smith,
sir.
thank you.
Thank you so much, sir.
Yes, thank you very much.
Thank you, sir.
Yeah,
Thank you.
thank you, thank you.
Have a
Okay.
great day, sir. Thank you so much.
Thanks.
Thank you.
Dear participants, I will share link on a WhatsApp group. Please respond that feedback link, and after your response, you will get e-certificate on your mail. So I conclude here that this one-day seminar, chemistry for innovation and sustainable development, is over here. Thanks all of you. Ma'am,